Task-specific sensor planning for robotic assembly tasks. We compute task-specific uncertainty measures via open-loop operators and embed this approximation into robotic assembly planning. Task-specific uncertainty measures approximate the success probability for a task. Not all degrees of freedom are made equally important for every task. For example, inserting a key is very sensitive to rotation, but not insertion translation. Next best view algorithms therefore have to take into account the task at hand to get meaningful informative poses. We use an open-loop planner to estimate pose quality using likelihood from the ICP algorithm. We incorporate the resulting uncertainty measure into an assembly planner, planning for both the manipulators and the sensor poses, and taking into account both grasps and the resulting occlusions. This is a set of examples of the plans generated by the planner. We now show block insertion task examples using 3 KUKA robots. Other tasks that we performed include peg-in-hole and block stacking. In this video, the 2 manipulator robots start on the right, and the sensor robot starts on the left, equipped with a Kinect sensor. The robots grasp the parts and move into position to insert the parts. This phase is highly sensitive to exact positioning, and the sensor robot must help better align the parts before insertion. For this phase, we therefore have to reason about the pose of the sensor, and here we use the approximate open-loop operator. The manipulators can now proceed using the corrected poses to complete the insertion tasks. For more details on the algorithm, the scenarios, and the paper, please come to our poster. Thanks.